Okay, 1 point for part one is some review of just uh, solving some, I don't know, 2 or 3 step equations and reviewing some fractions too as we go along here. So let's look at the first part, part A, where we have 4x plus 7 equals 27. And the first thing I'm going to do here is get my variables on one side. So here's my variable term, 4x. So I want to get that on one side of the equation and the number on the other side. Now, if it helps, draw a dotted line there because whatever you do to one side, and you have to do it to the other. Now, it also helps you keep things straight because I see students many, many times, even in Algebra 2, that they do the same operation to the same side. So I want to get rid of this 7 or undo the 7. So I'm going to subtract 7 from both sides. Okay, so I get my positive, or my 4x I have to bring down. Positive 7 minus 7 gives me 0. And because I have a term there, I don't need to put the 0 there. So these just cancel out. Now, if I didn't have the 4x there, I would have to put a 0 there. Equals 27 minus 7 is 20. Then I have to undo the multiplication because that 4 is a coefficient of x. It's a number being multiplied to the variable. To undo multiplication, I divide both sides by that coefficient 4, and I get x equals 20 divided by 4 is 5. There's my solution. Number 2, here's my x term. Just because that 5/2 is a fraction, it's still a number. Just like the 4 is a number, we treat it the same way. So I'm going to go ahead and get rid of the 1 or undo the minus 1 by adding 1 to both sides. Bring down my 5/2 x equals 19 plus 1 is 20. Now, I keep telling my algebra, even in Algebra 1 and Algebra 2, the easiest way to get rid of a fractional coefficient, and you should be doing this in Algebra 2 by now, is multiply both sides. Now, normally you'd multiply both sides by 2 and then divide by 5, but you should be able to, by now, in your mathematical lives, multiply both sides by the reciprocal. Because what happens is these cancel out. I get my x and 20. Now, if you're not very good at multiplying fractions, go ahead and put it in the calculator. But many times students, again, at this point in their mathematical lives, could probably do this in their head. Let's see, 20 divided by 5 is 4. 4 times 2 is 8. Or put it in the calculator. But when you put fractions in your calculator, please make sure to use parentheses. So I have 20 times 2 divided by 5. Let's go on to part B. So solving equations with variables on both sides. So we have to follow the same situation. We have to get the variables on one side first and then isolate that variable. By the way, that is what we're doing here, solving algebraic equation is isolating the variable, getting the variable by itself. That's the whole way. That's exactly what we're doing. Okay. So I have 3a plus 13, and this is where I start putting in those dotted lines because we got a lot going on and kind of where students make the mistakes. So I want to get the variable on one side first. That's the way I do it. You don't, there's different ways of doing it. If you have another way, fine. So I'm going to subtract 3a first. Now, you could subtract the 9a, that's fine. Either way, like I said, either way is going to work. But I like subtracting a lower one from the higher one because it keeps it positive. Subtract 3a. Again, make sure you're doing like terms. You're not putting the 3a over here or subtracting the 3a on the same side. Again, a lot of arithmetic mistakes that it keeps seeing. So I get 0. You don't have to put the 0 here because I'm bringing down that 13. Equals 9a minus 3a is 6a. Don't forget to bring down the minus 8. Now, I'm almost there getting that term by itself on one side, the variable term. I have to undo the minus 8. I'm going to add 8 to both sides. See how that dotted line helps me? So I get 21 equals 6a. These cancel the 0, don't need the 0. And then I'm going to divide by the coefficient. 6 to get a by itself. 6 is canceled. I get my a. And 21/6 reduces to 7/2. And that's my answer. Now again, you're a little rusty reducing fractions. Here's your calculators. Let's see, I got 21/6. And actually, you don't need parentheses doing this. Hit enter, get a decimal, hit the math button, enter, enter, and it gives you the reduced fraction on your calculator. By the way, on all the Chromebooks, you can download that TI-84 scientific calculator app. All right, number 4. Now this time we have a number in front of parentheses. So you're always going to have to do distribution first. So I have 4 times 3x gives me 12x. 4 times 1, 4. 10 times x is 10x. Positive 10 times positive 4 is positive 40. Please be careful. Don't distribute to the minus 7x. It's outside the parentheses. Just bring it down. So the next thing I got to do, and this is up to, I've seen a lot of students actually leave these separated. Personally, I like to combine like terms on the same side first. So I get my 12x plus 4 equals 10x minus 7x, 3x plus 40. Get my variables on the same side of the equal sign. So I'm going to bring this 3x, undo the 3x because it's lower than 12x. My preference, I'd like to keep them positive. You could certainly minus 12x. 12x minus 3x, 9x. Bring down the 4 plus 4 equals, I don't need a 0 here because I'm bringing down the 40. Get my numbers on the other side. I'm going to undo plus 4 by subtracting 4. I get 9x equals 40 minus 4 is 36. Divide 9x by the coefficient 9. And 36 divided by 9 is 4. See, I was thinking ahead. Okay, part C, proportions. They even give you a hint. Cross multiply. It's actually called cross products. Somebody made a mistake. Okay, when you have a ratio equals a ratio, it's called a proportion. Or in other words, a fraction equals a fraction. Now, these fractions have to be by themselves. And we'll get into that in this number 7. But since these ratios are reduced to one term, I go ahead, multiply the 10 and the 3 equals the 7 and the x. Go ahead and solve. 10 times 3 is 30 equals 7x. Get the x by itself, so undo the multiplication of 7 times x. Divide by the coefficient 7. And I end up with the answer 37 equals x. Now, in number 6, I highly suggest you immediately put parentheses around two terms when you're solving, especially when you're solving proportions. Because what's going to happen when you cross multiply 6 times x plus 2, what's going to happen is many students won't multiply or distribute that 6 to the 2. They'll just put down 6x plus 2. With those parentheses, it forces me to look at it as a quantity. And then I get 4 times the quantity x minus 3. Now it shows me here more clearly with those parentheses that I have to distribute. 6 times x, 6x, 6 times positive 2, positive 12, 4 times x, 4x, 4 times negative 3, negative 12. And then go ahead and solve for x. I'm going to subtract 4x from both sides. I get 2x plus 12 equals negative 12. Here, I'm going to undo positive 12 by subtracting 12. Both, again, if it helps you, put the dotted line there. So I get 2x equals minus, this is not 0, not negative 12 minus 12 is negative 24. Divide both sides by 2, the coefficient, and I get x equals negative 12. And 7 is that tricky proportion I was telling you about, where you have to get the variable term by itself first. So you have to minus or undo that plus 4 by minusing 4 to both sides. Then I get that negative 2x plus 10. And I'm going to go ahead and put this in parentheses just because I don't want to make a mistake. Over negative 5 equals, now 13 minus 4 is 9. And you're saying, well, I don't have a fraction equals a fraction. I can't do cross multiplication. But you do have a fraction on the right-hand side. Whole number can always be represented by the number 1. Go ahead and cross multiply. 1 times, well, negative 2x plus 10 times 1 is just going to be negative 2x plus 10. Anything times 1 is itself. Equals 9 times 45, or negative 5 is negative 45. Solve for x. Subtract 10 from both sides. I get negative 2x equals negative 55. Divide both sides by the coefficient, negative 2. And you could either leave it as x equals negative 55 over negative 2, which is the same thing as saying x equals 55 over 2. Either one is the correct answer. Okay, let's look at lowest common multiples. And we kind of threw this in here because, again, many of you are rusty when we find that many of you are rusty when it comes to lowest common multiples. In other words, when you add fractions when back in 4th or 5th grade, suppose you wanted to add 1/2 plus 3/4. You couldn't just add, well, 4 over 6. You couldn't do that. You needed a lowest common denominator. So here, my lowest common denominator, or multiple as we call it in Algebra 2, was 4. So then I would have to change this to, well, have to have a 4 in the bottom. In order to make 2 a 4, I multiplied it by 2, so I have to multiply the numerator by 2. 1 times 2 is 2, plus 3/4. Now I can add the top numbers, get 5/4. So it's really important that we remember or figure out how to get lowest common multiples. Now this is the way I do it, and I teach my students to do it. Like sometimes it's really hard, especially when you start getting 3 numbers or really high numbers or a wide difference of numbers. I look at that highest number. Okay, I look at the highest number, 5. Okay, 5 times 1 equals 5. Does 4 divide into 5 evenly? And no, it doesn't. You can even check on your calculator. 5 divided by 4 gives you a decimal, so it doesn't work. So then I look at the next number, 5 times 2, 10. Does 4 divide into 10 evenly? 10 divided by 4, nope, it's a decimal, so that doesn't work. 5 times 3, 15. Is 15 divided by 4 going to be a decimal or a whole number? It's going to be a decimal. Then I look at the next one. 5 times 4 equals 20. And I know 4 is going to divide into that because I multiplied it by 4. So 20 is the lowest common multiple for 5 and 4. And again, you can always get a common multiple by multiplying all the numbers together, but it's not going to be the lowest. In Algebra 2, you're going to want the lowest common multiple. Otherwise, when we get to rational expressions, it's going to be a nightmare. Okay, so now the next one, 2, 4, and 3. I'm looking at 2, 3, 4. So I take my highest one. Let's see, 4 times 1 is 4. 2 divides into 4, but not 3. So that's not good. 4 times 2 equals 8. Let's see, does 2 divide into 8? Yes, it does. Does 3 divide evenly into 8? Nope. 4 times 3 is 12. Now this time I know 3 is going to divide into this because I multiplied it by 3. So 3 is going to work. Does 2 divide into 12? Well, yes, it does, mainly because 2 divides into 4. So this one, my lowest common multiple, is going to be 12. Okay, next, part D, equations with fractions. And again, I'm telling you, it's going to be a whole lot easier using a calculator on these. But if you don't, You're going to have to do it manually. And this is how you do it manually. And sometimes we're really mean being math teachers. And we'll say, well, you got to show your work. You got to find the lowest common multiple. And you have to use that to find out what x is, isolate variable. So the lowest common, and remember, any whole numbers, even x, is over 1. So my denominators, 1, 6, 12. So I'm going to take my highest one, 12. Does 6 divide evenly into 12? Well, yeah, it does. 6 times 2 is 12. Does 1 divide? Well, 1 divides evenly into everything. So my lowest common multiple here is 12. Now here's what I'm going to do. I'm going to multiply my entire equation here by that lowest common multiple, 12, or 12 over 1. Okay? I have to distribute it to each and every one of these terms. 12 times x, 12 over 1 times x over 1. Now the whole idea here is to eliminate fractions by multiplying by the lowest common multiple. If you don't eliminate these fractions, did something wrong. 12 times x over 1 is 12x over 1, or just 12x, minus, now, again, you might be able to do this in your head. 12 divided by 6 is 2. 2 times 5 is 10. And if you don't like it, do it in your head, by all means, you can do this part in the calculator. 12 times 5 divided by 6, or 5 6, equals 10. Equals, now here, 12 over 1 times 1 over 12, they're going to cancel, and I get the number 1. Again, you can do it in your calculator. Now I'm just going to solve for x. Add 10 to both sides. I get 12x equals 11. Divide by the coefficient 12. And I get x equals 11/12, which is reduced. I'm done. Okay, number 9, my lowest common multiple. Again, this is over 1. So I'm going to take my highest one, which is 5. And we actually did this on the other side. Remember, we had 4 and 5. And we knew that the lowest common multiple was 20. So I know that the 4 and the 5 goes into 20. I know 1 goes into 20. 1 goes into everything. And 2 goes into 4, and 4 goes into 20. So I know 2 works. So my lowest common multiple is 20. Going to multiply the entire equation by 20. 20 divided by 4 is 5. 5 times 3 is 15. Don't forget the x. Bring down the minus sign. 20 divided by 1 is 20. Times 2 is 40. 20 divided by 2 is 10. 10 times 5 is 50. Don't forget the x. 20 divided by 5 is 4. 4 times 1 is 4. Now I solve for x. I'm going to subtract 15x from both sides. Be careful, bring down the minus 40. 50x minus 15x is 35x. Bring down the 4. Subtract 4 from both sides. Negative 44 equals 35x. 4's cancel. Divide by the coefficient, 35x. Yeah, that's right, 35. Thought I made a mistake. So x equals negative 44 over 35. And you could leave it this way, or you could put the x first. Doesn't matter. Okay, word problems. We're going to go a little more into word problems in the next section. So this is just kind of like a start of it. Let's see if we can set these up and solve it. A real estate broker's base salary is $18,000. She earns 4% commission on sales. How much must she sell to earn $55,000 total? Now, let's think about what the total was made up of. Let's see, she gets a base salary. So she gets that base salary. And we want to do this with word problems pretty much all the time because we want to do a verbal model where it's always, that's how we always figure things out in real life. We don't like go up to our boss and says, 18,000 plus X equals her 55,000. So we have to make a verbal model. So it's her base salary, and then she earns a commission, right? She also gets a commission or whatever percentage it is. That equals her total salary. So now we've got to start, what we do is what we're going to like, we define a variable here because we don't know how much she has to earn. So our unknown here is the commission. That's going to equal our X. So my base salary, 18,000. Base salary is 18,000. Plus the commission, 4%. And we don't know how much of 4% of what. That's what we need to find out. So it's our total sales. X is our total sales. Commission on total sales. We should define this. X equals the commission on total sales. I should have defined that earlier. So 0.04x, 4% of that total sales is what I get. And that's going to equal her salary of 55,000. So now I go ahead and just solve for x. So I need to get my variables on one side. I'm going to subtract $18,000 from both sides. Hey, look, it's kind of like paying taxes. Gets wiped out. Your money gets wiped out. So I got 0.04x equals, let's see, 37,000. And I'm going to divide by the coefficient. It's a decimal, it's okay. 0.04 on each side. And if I'm going to have to use a calculator. Brain's not working that great. So I've got 37,000 divided by 0.04. And that gives me $925,000. So she's got to sell quite a bit. She's got to sell $925,000 worth of houses and stuff. And the last one, you have a summer job that pays $5.60 an hour. You get $8.40 an hour for overtime, anything over 40. So how many hours of overtime must you work? So let's do another verbal model. Let's see, your regular hours plus your overtime hours is going to equal your total pay. Okay, so we don't know here. We know the regular amount of hours here is going to be 40, right? So regular hours is 40 hours. And we know what that regular pay is, 560. This is all given. Plus the overtime hours. Well, I don't know how many overtime hours I have. So I'm going to have to, that's going to be my variable, is that number of hours of overtime. We're going to let X equal the number of overtime hours. And for each number of overtime, for each hour of overtime hours, I get paid, well, that's given, $8.40. I just don't know how many hours I'm working. That's where my variable goes. The total pay is given to me, and that total pay is 287. So now I got to solve for X. 560 times 40 gives me 224 plus 8.4X. I'm going to drop that zero. Equals 287. Get my variables on one side, so I'm going to undo the positive 224 by subtracting 224 from both sides. I have, excuse me, 8.4x equals 3, 6, 63. Going to divide 63 by the coefficient 8.4, and I know that he worked 7.5 hours. And that's it for section 1.4, part 1.